idea of climate change. Professor Plato.
Well, thank you for coming. I'm a geologist, and the one thing that we miss out on in looking at climate change is the past. Climates have always changed. Climate changes in the past have been greater and faster than anything we experience in our lifetime. And sea levels have always changed. Not by the modest couple of millimetres that people are having conniptions about, but we've had in the past sea level changes of only 1,500 metres. That's a sea level change. And if we look back in the history of time, the atmosphere once had a very large amount of carbon dioxide in it. It's now got less than 0.04%. Where did that carbon dioxide go to? It went into chalk, limestone, shells and life. And we've been sequestering carbon dioxide out of the atmosphere for only 2,000 to 500 million years. This planet has been degassing carbon dioxide since it first formed on that Thursday 4,567 million years ago. Carbon dioxide is a natural gas. It has dominated the atmosphere for an extraordinarily long period of time, and we now are at a dangerously low level. If we halved the amount of carbon dioxide in the atmosphere, we would have no terrestrial plants. Carbon dioxide is plant food. It is not a pollutant. To use words like pollution with carbon dioxide is misleading and deceptive. But the past gives us a wonderful story. In the past, we've had 6 major ice ages. We are currently in an ice age. It started 34 million years ago when South America had the good sense to pull away from Antarctica, and there was a circumpolar current set up which isolated Antarctica, and we started to get the Antarctic ice sheet. We've had periods of glaciation and interglacials. We are currently in interglacial. And during that 34 million years, we have refrigerated the Earth. But for less than 20% of time, we have had ice on planet Earth. The rest of the time, it's been warmer and wetter. And there's been more carbon dioxide in the atmosphere. And what did life do? It thrived. 6 of the 6 great ice ages were initiated when the carbon dioxide content of the atmosphere was higher than now. In fact, up to 1,000 times higher. So we have, from the geological evidence, absolutely no evidence that carbon dioxide has driven climate. For some odd reason, the major driver of climate is that great ball of heat in the sky, which we call the sun. You heard it here first. It's really quite unusual. And we change our distance from the sun. Every 100,000 years, our orbit changes from elliptical to circular. And we have a cycle of 90,000 years of cold and 10,000 years of warm. We're in one of those warm cycles now. And every 43,000 years, the axis of the Earth changes a little bit. And every 21,000 years, we get a bit of a wobble. Each of those orbital events put us further from the sun. Every now and then, we get bombarded by cosmic rays coming from a supernova eruption somewhere out there. And if the sun's magnetic field cannot drive these away, we start to form low-level clouds. We've got extremely good evidence that this process has been going on for a very long period of time. Every now and then continents start to move, and they move at very rapid rates. They move about this much every year. And at one time a continent can be over a pole, at another time it can be at the equator. Those moving continents change the major heat balance on the Earth. And that's the ocean currents. The oceans carry far more heat than the atmosphere. Every now and then, because of major geological processes, we'll get a great bulge on the ocean floor of new volcanic rock. That changes ocean currents. Every year we have 10,000 cubic kilometres of seawater that goes through new volcanic rocks in the ocean floor. That exchanges heat. The reaction between seawater and the rocks stops the oceans becoming acid. When we run out of rocks the oceans will become acid, but don't wait up. It will be a long time. We see 1,500 terrestrial volcanoes on planet Earth. We only measure 20 of them, and very few of those measurements are really accurate, but they tell us that a little bit of carbon dioxide leaks out of those volcanoes. But what we don't hear is that there are at least 3.47 million volcanoes on the sea floor which leak out huge amounts of carbon dioxide. We have got pools of liquid carbon dioxide on the sea floor. So, early Earth's carbon dioxide, where did it go? It went into rocks. Where did it come from? It came from rocks. What did it do to the planet? We did not fry and die. We didn't have runaway greenhouse. Well, that's just geology. That's not important. So let's look at more modern times. In more modern times, we have drill cores that have gone through the ice sheets. Snow, when it falls, captures some air. That air is then trapped in the ice. We can later extract it from drill core and measure the amount of carbon dioxide in the air. And we can see with our cycles of glaciation and interglacials that when we finish an interglacial event, then we release carbon dioxide some 800 years later. So what's that telling us? It's telling us that temperature is driving carbon dioxide, not that carbon dioxide is driving temperature. Oh yes, but that's only hundreds of thousands of years ago, forget that. Well, let's go to more modern times. We've been measuring temperatures accurately since 1850, and the accuracy is plus or minus 1 degree Celsius for those ancient measurements. We are being told that this 0.7 degrees Celsius rise is going to create a disaster. I've only got to move over to here, and I've had a 0.7 degree Celsius temperature rise. Where do you people go for your summer holidays? You go to a warmer climate. We are creatures from the Rift Valley. We like warm climates. If someone from Helsinki moves to Singapore, there's an average temperature rise of 22 degrees Celsius. Singaporeans don't drop dead in the streets from the temperature. So we are creatures of warm climates, and we've been measuring temperature, and we have seen a slight warming from 1860 to 1890, and then a slight cooling until 1910, then a warming until 1940, so much so that the Northwest Passage was open, then a cooling until 1977, and then a warming until the end of the century, and now we're in a period of cooling. So we've had these cycles of warming and cooling. Strange that these cycles are actually related to changes in the heat balance in the oceans. So we have these 60-year cycles over a long warming event. We are in a period of global warming. It has been warming since the Maunder minimum 330 years ago. These were the times when you had the ice fairs on the Thames. These are the times when the Dutch masters painted hoarfrosts and bitterly cold conditions. That was the time when the sun was a bit inactive and we had no sunspot activity. So we're in a long period of warming, and one of the questions that I ask in this book is which part of the last 330 years of warming is due to human activity and which part is natural? These are questions that kids should ask their school teachers, and they're deliberately unanswerable questions, because I am of the view that many children are getting fed environmental propaganda in the schools and are not being given the critical and analytical facilities to be able to dissect an argument. So we're in a period of warming. What's the worry? It's quite normal. And let's just look at history. And the one thing that the climate industry, which it is, ignores is history. In Roman times, it was warm. It was considerably warmer than now. And we know that. They kept good records. They grew olives up the Rhine River as far as Bonn. They had wine grapes in Yorkshire. We know from their clothing that it was warm. Possibly they were going to an orgy, but I think it more likely it was warm. And that warming suddenly stopped in 535 AD. And we entered the Dark Ages. And in 535 AD we had Krakatoa fill the atmosphere with aerosols. And it wasn't a big volcano. Only 30 cubic kilometres of aerosols go into the atmosphere. We've had bigger ones in Yellowstone. We've had even bigger ones in New Zealand, where 10,000 cubic kilometres of aerosols have gone into the atmosphere, and we pray for another one, because that's the only way we'll ever beat them at rugby. Just wipe them out. We had 2 volcanoes, one in Rabaul and one in Krakatoa in Indonesia in 535, 536. We went into the Dark Ages. It was cool. What happened? Crops failed. We starved. We had civil unrest. We had cannibalism. We broke out of that into the medieval warming. First to feel it was the Vikings. The seas became calmer. They could go further fishing. They actually went to Newfoundland, which they called Vinland. In Greenland, grapes and barley were growing. In Greenland, the graves were deep because there was no permafrost. It was a wonderful, benign climate, 5 degrees warmer than now. Eric the Red was saying, come to Greenland, it's a wonderful climate, and it was. And then we went through a period of solar inactivity, and in 23 years, we went from the medieval warming into the Little Ice Age. And that Little Ice Age ended 330 years ago. So what do you think would happen after a Little Ice Age? Do you think it'd get colder, or do you think it'd get warmer? The only reason that the arguments of science have got any traction in society is that they have been related to the last 30 years or 40 years of temperature measurements. I see with great interest the Met Office is telling us that this is the hottest year on record, but you might be on a different calendar to me, but I don't think this year's finished yet. And this time last year I was in London, as I was the time before, the year before, and it was miserable. It was cold. It was very cold. So those sort of predictions made just before a big climate conference, one has to be very sceptical of. So in science, scepticism is not a pejorative word. In science, there is no consensus. In science, there are constant battles. A good example, we all knew that we got ulcers from an acid stomach and from stress, so we took pills and rubbed our bellies and hoped the ulcers would go away, until 2 scientists who were not following the mainstream, who were not following the consensus, were arguing that this was due to a bacterium, and no one listened. Ultimately, one of them took the bacterium, developed ulcers, took the antidote, and for that they get a Nobel Prize. You do not get a Nobel Prize for following the consensus or saying the science is settled. I believe we've had an enormous corruption of science and the scientific method. I believe that the monies that are floating around for climate research, which is a current fad and fashion, are quite perverse. I believe we're putting science backwards, and come the next inevitable pandemic, we may not have the weapons to handle it. We might go waving herbs and chanting rather than creating an antidote. So this, for me, this climate industry has been a huge attack on the scientific method. It has been an attack on my science and history, and things, fortunately, are changing. I finish with one last point. You've got your Climate Change Act. We've just had a carbon tax in Australia. 19 bills went through Parliament, and our carbon tax is to lower the emissions of carbon dioxide from our employment-generating industries in Australia. And it's wonderful. We've led the world in suicide. And our carbon tax is to knock down our emissions by 5%. Now, you can do the sums. And the sums are very simple. The IPCC says that 3% of annual emissions are from humans. Why is it that that 3% drives climate change is beyond me and not the other 97%, but that's another matter. Australia puts out 1.5% of the world's CO2 emissions. You can do the calculations, and by Australia knocking back their emissions by 5%, we will, by the year 2050, have lowered global temperatures by 0.00007 degrees Celsius. So I do hope you enjoy our sacrifice in giving you a warmer climate here in England. Thank you.
Excellent.